everyone, welcome to Epsilon Pro Academy. In today's lesson, we will be looking at application of differential calculus under stationary point, maximum and minimum point, and also turning point. First, let's know the meaning of stationary point in calculus. Stationary point is a point on the curve where the gradient, that is the slope, is 0, where the slope gives 0. Mathematically, we can express mathematically dy over the x, or the gradient of the curve, is equal to 0. And this is what we call stationary point. Now let us consider a function where y is equal to x raised to the power of 2 minus 6x plus 4. Okay, in this function on the board, y is equal to x raised to the power of 2 minus 6x plus 4. What is the stationary point of this function? In this question on the board, the idea is that at stationary point, the y over the x must be equal to 0. Because the y over the x is equal to 0 at stationary point, that means we have to differentiate or find the y over the x. That's the first thing we must obtain. So at stationary point, solution dy over the x of this function is equal to differentiate this function, use this power to multiply by this term, that is 2x, then subtract 1 from it, which is 1, minus, to differentiate 6x, we are going to have 6, then to differentiate the constant term, we obtain 0. So dy over the x gives 2x minus 6. But the idea is that at stationary point, dy over the x is equal to 0. So that means this 2x minus 6 should be equated to 0. And we have 2x minus 6 is equal to 0. 2x is equal to, when 6 crosses over, it will become plus 6. To make x the subject, divide the two sides by the coefficient of x, which is 2 and 2. So 2 cancels 2. At this point, you are going to be left with x is equal to 6 over 2. That is, x is equal to 3. So stationary points occur at x equal to 3. Now let us determine the y coordinate. How do we get the y coordinate? Y coordinate can be determined from the original function given on the board, where y is equal to x squared minus 6x plus 6, plus 4 rather. So to get y coordinate, determine y coordinates. So that means y is equal to x squared minus 6x plus 4. And y is equal to x is 3. That is 3 raised to the power of 2 minus 6 times 3 plus 4. And y is equal to 3 raised to the power of 2 gives 6 minus 6 times 3 is 18 plus 4. Y is equal to 6 minus 18 plus 4 is minus 8. Therefore, stationary point is, so at stationary point, x is equal to 3 because dy over the x gives 0 and x equal to 3. Then to determine y coordinates, we obtain minus 6. In every point in the coordinates, it is always x, y. So stationary point is xy. So x is 3 and y is minus 8. Take note, at any point in the coordinate system, it is always represented with x, y. Take note of this concept. Let's consider example number 2 on the board. The question is y is equal to 2x raised to the power of 2 minus 20x plus 46. What is the stationary point? Now this is very simple. When it comes to stationary point, the first thing we have to obtain is to determine dy over dx. So solution, dy over dx is equal to, the concept of differentiation is that this times the term. Always multiply the power by the entire term, then subtract 1 from the power. So if I multiply 2 by this, I will have 4x. Then subtract 1 from the power, which is 1, minus the same over here, which will give 20. Then if you differentiate the constant term, you obtain 0. That is the first approach. So dy over the x gives 4x minus 20. The concept of stationary point is that dy over the x must equal to 0, or the gradient must be equal to 0. That means 4x minus 20 is equal to 0. Making 4x the subject, 4x is equal to 20. And making x the subject, x is equal to, if you divide both sides of the equation by 4, we obtain x equal to 20 divided by 4. So x is 20 divided by 4, and x is equal to 5. So at stationary point, x is equal to 5. How do we determine y coordinates? Determine y coordinates. So that will give, from the original function given on the board, y is equal to 2x raised to the power of 2 minus 20x plus 46. So we can get the y coordinates from the function. So that means y is equal to 2x raised to the power of 2 minus 20x plus 46. So y is equal to, when x is 5, let's substitute 2 bracket open 5 raised to the power of 2 minus 20 bracket open 5 plus 46. So y is equal to, 5 raised to the power of 2 is 5 times 5, which gives 25. And if you multiply 25 by 2, we obtain 50. Minus 20 times 5 is 100 plus 46. So y is equal to, 50 minus 100 gives minus 50 plus 46 gives minus 4. Therefore, the stationary point is, bracket open x, y, and x is 5, where y is minus 4. That is the basic concept of stationary points. Now let's look at turning points.